All right, let's get cracking on it. Richard's got a question. He says, running a fairly soft material, acetylene wood, on a WinCNC control shop saver router. When I use the adaptive toolpath on a slot that is 10 millimeters wide with a quarter-inch cutter, so I mean, quarter-inch is what, a little bigger than 6 millimeters.
Yeah.
Runs into starvation issues. Same path as on a Haas. NGC, no problems. Lots of small moves. Yeah, I mean, so let me share my screen while we're waiting for Angelo to get on here. Let me just make a thing here. So I mean, we'll just make kind of a 1-for-1 example here. We don't really care how big this is. We're gonna go to create a sketch on the top. I'm gonna hit S and grab the slot tool. I also noticed a ton of time on the last week's where I wasn't saying anything. We'll put in 10 and then type in MM. We'll hit E for extrude to quickly cancel that. We'll drag that down by a small amount. Go into manufacture here, make our stock fixed size, round up to the nearest 0.
Yeah, Richard says that he has a model, but it's basically pretty simple with a 10 millimeter wide slot, 30 millimeters long.
Yeah, I think we got the length of it doesn't really matter.
Yeah.
Hopefully
Hello, everybody.
Oh,
Hello, sir.
What is
Thanks.
cracking?
Thanks for finally joining us.
Yeah.
What's cracking?
Welcome.
Thank you.
I'd always
Good to
set
be
your
here.
RAM clearance height something low too, just BT dubs. Otherwise, it's gonna do like 3, 4, 5 cuts above. Why does this happen? Empty toolpath. Angelo, can you tell me why?
Why does what happen?
Why does the tool not enter the material? Minimum ramp diameter.
There you go.
I wonder if there was a weekly challenge on that.
Very common customer issue. So
Very
let's
common issue. Yeah.
toolpath visibility, and we will go to show points. The other thing we're going to do here is pop this open, and we're going to look at this. It is 103 kilobytes. So on the Haas or on like a modern control, it's not really. This really isn't going to make too much of a difference. Most controls can process, a fair amount of blocks. I remember back in the day, I think the Haas was like 1200, and if you had high speed, it was like 2500 characters a second that it could read or process. From what I understand, obviously, I'm just a silly machinist. Nowadays, the Haas is, I believe, 2500, and with high speed, it's about 5000 characters a second that it can process. So depending on your machine, your control, you may have mixed results here, and it sounds like that's what Richard's running into here. One thing I want to do here is let's leave this one like it is, and because this is 2D adaptive, it's not looking for any sort of rust material. I'm just going to duplicate this one, and we have both here that have 103 kilobytes. If you wanted to fix this or alter this, a couple things we need to take a look at. We're leaving 20 thousandths of material on the walls here, so we could obviously leave a little bit less. That's probably a lot for a finishing pass. A cutter this type, but I'm going to leave it just so we have 1-to-1. I'm going to go to smoothing, and I want to make sure that the number between tolerance and the smoothing tolerance and the tolerance is not greater than this number, and I probably want to leave about 25% of that. So I wouldn't ever want these numbers if I'm leaving 20. I wouldn't ever want this to be greater than 15. So what I'm going to do is put in 0.004 here, so I have a 4 thousandths tolerance on my smoothing, and I have a 4 thousandths tolerance on my toolpath. So at most, I'll be 8 thousandths, and because I'm leaving 20, we got about 12 thousandths of leeway there if something goes wrong. I'm going to hit OK on that, and we'll notice that this gets cut in half. This goes to 58 kilobytes. And if we look at this one and we select it, we'll see really the main source of points now is actually coming from the retract, from the linking move here, because the cutting move is actually just one arc move. And you can also do this by right-clicking on the toolpath, going down to Show Toolpath Data, and you can see here, this is all the data for the toolpath. So we can scroll down to the bottom here. We got about 729 lines of code. You'll notice that in these lines of code, we have a fair amount of linear and circular moves and whatnot, but the meat of these circular moves are going to make up what the other one was doing. So we cut this code in half. We can right-click on this one and do the same thing. long as I right click on the operation and not on the setup. Show Toolpath data. If you look here, we do have some circular moves, but we're going to end up with a lot of linear moves here. And a lot of these linear moves are what we're seeing here. We're seeing kind of these little linear moves that join that together. We are seeing some circular moves in there, obviously, I think the beginning of the path of this helix, but other than that, most of this is going to be made up of, linear moves in really, really small arcs. So hopefully that makes sense. I mean, this would be the best way to fix it. Obviously, the bigger the tolerance you give it, the more it's going to be able to fit arcs in there, and the smaller amount, the toolpath will be smaller. You'll have smaller amount of characters and whatnot for it to analyze, and that should help with bringing the data starvation like you're talking about, Richard. Does that make sense? Any of my esteemed colleagues have anything to add to that?
Oh, I got two
Yeah.
things. One on the adaptive, you can change the retracts or the linkings to not stay down and just come up and wrap it over, so you can bring down some points that way instead of for most things. But the biggest one, Richard, since you're using Estel and wood, and you're getting data starving issues, I would almost forget about using the adaptive path and just use a 3D or a 2D pocket. This is going to be a lot lighter on the points and probably a lot faster to run.
Yeah, if you compare cycle time, it might be more efficient, depending on geometry of the model. I've seen it where,
especially just on, especially just those like really soft materials that you're not really taking advantage of what adaptive was made for.
yeah, adaptive doesn't do well on narrow walls, like where the spacing is rich, like just slightly bigger than the tool diameter. Like you got a 10 millimeter slot with a 6.35 millimeter cutter, then there's not a whole lot of wiggle room. And like Devin highlighted, the stock to leave also accounts. So when I come across features like that, I find that just doing like a slotted toolpath, even like you said, a ramp slot down, would be a quicker cycle time in that area. But you could always, maybe Devin can show it, see which one's faster.
Yeah.
If you were to do a ramp 2D contour with the ramp, yeah. And compare the cycle time with the same speeds and feeds.
You could probably make that ramp angle like 30 degrees.
I find it funny that the cycle time. Oh, it's the same. It's the same. I was looking at the wrong thing. Yeah, see, 17 seconds compared to a minute and 19, so a whole minute faster. So Phil highlighted that by bringing that up. Way more efficient on a geometry like that.
And you can,
Yeah, if you're doing soft material, that's perfect.
Yeah, for sure.
Yeah, you don't always have to change your ramp angle too. Sometimes, especially with tiny cutters, what I really want to control is the depth in between the passes. And you can do that here. You can leave the ramp angle what it is. It'll obviously, that's going to be what it's going to do, but it also defaults to this value here, the maximum step down. So if you set this to like 50 thousandths or whatever now you'll see I get quite a different path. So we're not necessarily going at that ramp angle that we selected there. Now we're going to, go at whatever ramp angle we have allotted. Obviously, we have to have that amount put in there, but it's going to limit it by whatever that step down distance is.
Yeah, and like Devin said, pay attention to that in the ramp height, clearance height, because I've had people where I think the default is what, 200 thousandths or 100 thousandths, and it's spinning above the part before it even hits.
The default's
Yeah, like
100. So here it's going to come
Default
down, it's going to go across, and all the way across, and all the way across, all the way across again. And we're not until our almost third path that we're going to touch the material.
Yeah.
Obviously, you want to not lie to it about what kind of stock you have. Make sure you're aware of everything that's going on there. But generally, I set this something super small, like 20 thousandths is enough. That way, it's going to move a little bit and start to enter the material.
Yep. And I'm going to use this strategy on profiling the outside of a part as well, not only slotting. Surprisingly, the wall surface finish is pretty clean when you use this.
I like to use contour. I think there's more options. You wouldn't use the slot toolpath in this case. The slot toolpath kind of negates whatever the outer contours are here and it just makes a centerline path. So using the slot toolpath, although it does produce something similar, we don't have any way here to offset it. You're going to get something like that.
Yeah,
But
regardless
cutter,
of tool
cutter
diameter.
won't be offset. Yeah, regardless of tool, you'd have a 3-inch tool in here, and it would do the same path.
I use that when I'm doing tabs on parts sometimes. Create some geometry and then zigzag it when I'm tabbing off. Yeah, good stuff.
We'll see everybody
Yeah,
next
good
week.
day. Yeah.
All right.
See ya.
See you guys. Cheers.
And until next time, stay sharp.